The question is, LM curve represents the locus of all those combinations of income and rate of interest which satisfy this condition. That is, supply of money, that is M upon P, should be equal to demand for money, and demand for money is a function of income and interest rate. For given values of M and P, what is the value of dy upon di? That means change in income with respect to change in interest rate. We need to find out this stuff. Options are being given. We need to find out the correct option. Okay. Now this LM curve or LM equation shows us the money market, equilibrium. Money market equilibrium occurs when the money supply is equal to money demand. We know that very stuff. Okay. Now M upon P, which is money supply. Money demand has two components, and let me write it in this fashion. Let's denote it by AY, okay, minus BI, okay. That means demand for money, L, which is a function of income and rate of interest. Demand for money is a positive function of the level of income and negative function of the level of interest rate. Okay, so in place of this, I have written this stuff here. Now, if I write this equation, and let me first write it in this fashion, let us write L, which is a function of income and interest rate, which is equal to AY minus BI. Let us first solve this. Okay, let's take the partial derivative of this function with respect to income first. So L and L dash y denotes the partial derivative of this function with respect to income. So derivative of y will be 1, so we are left with a. Similarly, L dash I denotes the partial derivative of this function with respect to interest rate. So derivative of I is 1, so we are left with minus b. And this I can write in this fashion, minus L dash I is equal to b. Okay, let's keep these in mind. Now if I solve this equation for y, so what will I get? So ay will be equal to M upon P, transposing it will become plus bi. Okay, again dividing both sides by a, we will get y is equal to 1 upon a times M upon P plus b upon a times I. We need to find out dy upon di. Let's take now the derivative, that is change in income with respect to change in interest rate will be equal to, since no I is involved in the first term, its derivative is 0. Derivative of I is 1, so we are left with b upon a. Okay, now what is b? B is equal to minus L dash I. Okay, it shows the interest sensitiveness for demand for money divided by A is equal to L dash Y, and this denotes the income sensitiveness for demand for money. Okay, so dy upon di is simply the ratio of the interest sensitiveness for demand for money and income sensitiveness for demand for money. Okay, so the correct option should be, I guess, L. We should have negative sign. We have negative in these two, so L dash I. So this D option should be correct option. The question is, for the utility function u, that is utility is a function of two goods x and y, which is equal to x times y, and the given budget constraint is total income is denoted by M, which is spent on two goods x and y, given the price of good x as px and price of good y as py. Okay, we have to find out the optimal bundle of consumption of good x and y. Options are being given. We need to find out the correct option. Okay, so since the consumer wants to find the optimal bundle, that means we want to maximize the given utility function, that is equal to xy subject to the budget constraint, that is price of x times units of good x plus price of y times units of good y should be equal to the total income of the consumer. Okay, now optimal condition requires that marginal rate of substitution between x and y should be equal to the ratio of the prices of good x and good y. MRS is simply the marginal utility of good x upon marginal utility of good y. It should be equal to price of x upon price of good y. Okay. In turn, marginal utility of x is simply the derivative of utility function with respect to x, and marginal utility of y is simply the partial derivative of utility function with respect to good y should be equal to the ratio of the prices, that is price of x upon price of y. So if I take the partial derivative of this function with respect to x, I will get derivative of x is 1, so I will be left with y. So du upon dx will come out to be y divided by du upon dy. That means partially differentiating this utility function with respect to y, so I will get x, because derivative of y is 1, so I am left with x should be equal to price of x upon price of y. Okay, what exactly is meant by this on the graph? Let's draw a small graph to save the space here. So we have good x and good y here. Okay, we have the budget constraint for the consumer. Okay, given this budget constraint, consumer wants to reach to the highest possible indifference curve. Let us say this is IC1. Similarly, we have IC2. Okay, so with the given set of given budget, consumer wants to reach to the highest possible indifference curve, and optimal bundle will lie at a point where the indifference curve and budget line are tangent to each other. Okay, now or we can say that when the slope of the IC and the slope of the budget line is same and they are tangent to each other, and this point, the tangency condition is, that is MRS should be equal to the ratio of the prices, price of x upon price of y. MRS is simply the slope of indifference curve, and the price ratio is the slope of the budget line. Okay, having said that, let us solve this for y. So we have y is equal to price of x upon price of y times x. Let us substitute this into the budget constraint. So here we put the value of y. So we get price of x times x plus price of y times the value of y is price of x upon price of y times x. Okay, should be equal to m. Now py and py gets cancelled, so px times x plus px times x, it comes out to be twice p x times x should be equal to m, which gives us x, that means demand for good x will be equal to, or optimal bundle of good x will be equal to the total income of the consumer divided by, if I transpose this, it will get divided, so twice px. Okay, this is the value of x. Now what is the value of y? Simply plug x is equal to m upon 2px here to get the value of y. Okay, so let us plug here the value of x. So our y will be equal to price of x upon price of y times the value of x is m upon twice px. Okay, px and px gets cancelled, that gives us y will be equal to m divided by py into 2 is twice py. Okay, so these are the these are the optimal combinations of good x and y. So x will be equal to m upon 2px, y will be equal to m upon 2py. So we have here, it is not the case. In the second one, we have m upon 2px, that means optimal consumption of good x. This denotes optimal consumption of good y. So that means option B should be correct. The question is, for a random variable x, it is given that expectation of x square is equal to 16 and expectation of x is 2. What is the value of variance for this distribution? Okay, so what we are being given? We are being given expectation of the random variable, that is expectation of x square is 16, and expectation of x is being given as 2. We need to find out the variance of the random variable. Let's denote it by x. var denotes the variance. It is being given by simply expectation of x square, okay, minus expectation of x but whole square. Okay, so expectation of x square is 16 minus expectation of x is 2, so it is square. It becomes 16 minus 4, which comes out to be 12. That means the variance of this distribution should be equal to 12. Question is to find out the solution of the difference equation xt is equal to 1 upon 2 xt minus 1 plus 3. Okay, so this is actually a first order linear difference equation. We need to find out the definite solution of this very equation. This is of first order because the greatest time lag is 1 here. Okay, and it is linear because all variables are raised to the power 1 and there is no cross product. Now the formula for first order linear difference equation for its solution is being given by, let's write the general first order linear difference here first. So we have, if we have yt is equal to byt minus 1 plus a. Okay, here a and b are the constants. Then the solution is, that is solution is equal to yt will be equal to y naught, that is initial condition, minus a divided by 1 minus b times bt plus a divided by 1 minus b. And this formula applies when b is not equal to 0, sorry, when b is not equal to 1. When b is not equal to 1, that means when this the coefficient of yt minus 1, that is b, is not equal to 1. Okay, and the solution will be equal to yt is equal to y naught plus at if b is equal to 1. Okay, now what is a and b in our equation? So in place of b, we have 1 upon 2, so this is our b, and a is this constant term. Then we can see the solution of this first order linear difference equation will be equal to, so in place of yt we have xt, so xt will be equal to, the solution will be equal to the initial condition yt. In place of yt we have xt, sorry, x naught, we have y naught. In place of that we have x naught minus a, in place of a we have 3 divided by 1 minus b is 1 upon 2 raised power bt, b is 1 upon 2 again raised power t, plus we have then a is again 3 divided by 1 minus b is 1 upon 2. Okay, I have explained all the intricacies of the first order linear difference equation in simple words. You can check out the playlist on differential equations. You will find out how this happens and what is meant by all this stuff. Okay, so check out the playlist on my channel. So our solution will be equal to xt will be equal to x naught minus, now 3 upon 1 minus 1 upon 2, so this is 3, 1 minus 1 upon 2 is 1 upon 2, so this becomes 3 2s are 6, so it sums out to be 6. Then we have 1 upon 2 t plus 6, that means xt is equal to 1 upon 2 raised power t x naught minus 6 plus 6. This is the definite solution of this first order linear difference equation. Okay, so we are applying this formula because b, which is 1 upon 2, is not equal to 1. If b was equal to 1, then we would have applied this very formula for getting the solution of this difference equation. The question is, evaluate the integral of e raised power 8 then natural log of x minus e raised power 4 natural log of x minus e raised power 4 natural log of x minus e raised power 2 natural log of x with respect to dx. Okay, now let us see here first the logarithm property is, if we have and let me write it here, if we have a natural log of x from the properties of logarithm, it is equal to natural log of x. This a becomes the exponent of x. Okay, this property we apply here. So what will we get? We get e raised power 8 ln x can be written as ln of x raised power 8. Similarly, here we can write e raised power ln of x raised power 4 using this property, divided by e raised power, again here ln of x raised power 4 minus e raised power ln of x square. Okay, and we have to evaluate it with respect to x. Another property is, if we have e to the power ln of x, this Euler's number and this natural log gets cancelled and we are left with x only. Okay, so here this e and ln gets cancelled in each of these terms, so we are left with the term x raised power 8 minus x raised power 4 divided by x raised power 4 minus x square, and we have to evaluate it with respect to x. Now we can do one thing, that is, let us take, and let me write it here, let us take x raised power 4 common in numerator. So we have x raised power 4, we are left with x raised power 4 minus 1, and similarly let's take x square common in the denominator, so we are left with x square minus 1 dx. Okay, after that we can do the thing here, that is x square and x raised 4 gets cancelled, so we are left with x square in the numerator and we are left with x raised power 4 minus 1 divided by x square minus 1 dx. Okay, now this x raised power 4, let me write it here, x raised power 4 minus 1, if I write it in this fashion, x square whole square minus 1 square. Okay, so this becomes an identity, that is a square minus b square. So in place of a we have x square and in place of b we have 1. We know that a square minus b square is equal to a minus b into a plus b. Okay, so our a is equal to x square, so we can write it in this fashion, x square minus 1 into x square plus 1. That means this term x square whole square minus 1 square is equal to this term. Okay, so in place of this x raised power 4 minus 1, I can write it in this fashion, that is, we have first x square, x raised power 4 minus 1 can be written in this fashion, that is x square minus 1 x square plus 1, in the denominator we have x square minus 1. Okay, so this x square minus 1 gets cancelled, we are left with x square and x square plus 1. Okay, still we are not integrating, we are just solving this dx. So we get x raised power 4 plus x square dx. Okay, now we can integrate it. The integral of x raised power 4 is x raised power 4 plus 1 divided by 4 plus 1. By power function rule, exponent is added by 1 and we divide it by the resulting exponent. Similarly, the integral of x square is x raised power 2 plus 1 divided by 2 plus 1. Plus we add the constant of integration. So this becomes x raised power 5 divided by 5 plus x raised power 3, that is x cube upon 3 plus the constant of integration. This is how do we solve this kind of question. It looked scary, but it was really easy. The question is, a consumer has a demand function for good x given by dp is equal to 100 minus p, where p is the price of the good x. If price of good x is $50, we need to find out the value of consumer surplus. Okay, so what we are being given? We are being given the demand function. That means quantity is a function of price. So in place of dp, I can write q is equal to 100 minus p. Okay, also the price is being given us as p is equal to 50. Okay, now to find out the consumer surplus, let us first find out the quantity brought at a price of 50. When p is equal to 50, so q will be equal to 100 minus, in place of p we have 50, so q also will be equal to 50. Okay, now if I draw the graph, it will make more sense. We don't use here the calculus method because it is very simple to use the graphical method. Okay, so if we have quantity here, price on this side, if I write this function, okay, on the graph, so let us rewrite this function here. So p will be equal to 100 minus q. Okay, I have written it into inverse demand function. No problem, you can graph it by this very function also. Now when p is equal to 0, when p is equal to 0, q will be equal to 100 here. Okay, let us say this is 100 here, and when q is equal to 0, p will be equal to 100. So we have this downward sloping demand function. Okay, also we are being told that at a price of 50, at a price of 50, so let us say we have a price of 50 here, quantity demanded is also 50. We need to find out the consumer surplus. What is consumer surplus? Okay, let me write it here. Here the intercept, price intercept is 100. Okay, now what is consumer surplus? Consumer surplus is simply the difference between the price that the consumer is willing to pay for a product and the price he actually pays for the product. Okay, so uh, the market price is 50. There will be other consumers who would have been happily to pay a price more than 50. Okay, some consumers will be happy to pay a price of 60 or 70 or 80 or 90 or 100. Since the equilibrium price or market price is 50, so the area of this very triangle denotes the consumer surplus. And simply, what is consumer surplus? It is the area which is above the market price or equilibrium price and below the demand curve. Okay, so the area which lies above the market price and below the demand curve denotes the consumer surplus. And here consumer surplus is simple. Consumer surplus will be equal to the area of this very triangle. And what is, since it is a right angle triangle, its area is being given by 1 upon 2 into base. What is the base of this triangle? So we have 0 to 50, so it is 50. And what is height of this triangle? So 100 minus 50, this is also here 50. Okay, so it is 50, which comes out to be consumer surplus will be equal to, let me write it here. So we have 1 upon 2 into 50 into 50 is 2500. So half of 2500 is 1250. Okay, so consumer surplus is equal to 1250. Okay, simple thing. When you have a linear demand function, it is really good to use the graphical method in solving the consumer surplus. It saves the time. The question is, if you draw a random sample of size 25 from a population whose standard deviation is 10, what will be the standard error of the sample mean? Options are 20, 2, 4 and 0.4. We need to find out the correct option. So what we are being given? We are being given the sample size that is equal to 25. Standard deviation is being given as is 10, and we need to find out the standard error. Okay, now standard error is simply equal to, and let me write it here, standard error is equal to the standard deviation upon under root of sample size. Standard deviation is 10, you know, n is 25, so this comes out to be 10 upon 25 can be written as 5 square. Okay, square and root gets cancelled, we get 10 upon 5, which comes out to be 2. That means standard error will be equal to 2. The correct option should be B option. The question is, an industry has two firms. They face an inverse demand function as P is equal to 200 minus 4Q. P is the market price and Q denotes the output of the two firms, and a constant unit cost of that is $8. That means that they have a constant marginal cost of $8 each. We have to find out the Cournot duopoly equilibrium price and quantity. Okay. Now what we are being given? We are being given this demand function, and I have written it here. P is equal to 200 minus 4. Now in place of this Q, I have written is Q1 plus Q2. That means this Q, okay, so Q industry output will be equal to the output of firm 1 plus output of firm 2. Okay, that's why I have written in place of Q is Q1 plus Q2. Okay, also marginal cost of firm 1 is equal to marginal cost of firm 2, which is constant, which is equal to 8 here. Okay, to find out the market equilibrium price and output in the Cournot duopoly, first we need to find out the reaction function of each firm. That means reaction function of firm 1. By reaction function, what we mean, it simply tells us how much output will firm 1 decide given the firm 2 has decided its output value. To find out the reaction function, first we need to find out the total revenue function of firm 1, which is equal to price into output produced by firm 1. This is our price function, so 200 minus 4Q1 minus 4Q2. If you solve it, to this we multiply by Q1. That is our total revenue function. Okay, that is 200 minus 4Q1 into Q1 is Q1 square minus Q1 into Q2. Marginal revenue of firm 1 will be simply the partial derivative of this total revenue function with respect to output of firm 1. So taking derivative of Q1 in the first term is 1, so we are left with 200. Derivative of Q1 square is 2Q1, so 2 into 4 is 8. Q1 derivative in the last term of Q1 is 1, so we are left with 4Q2. Okay, now we know that profit maximizing condition for each individual firm is he will equate his marginal revenue with its marginal cost. Okay, marginal revenue function is this. To this we equate it with the marginal cost. So we have 200 minus 8Q1 minus 4Q2 should be equal to 8. Solving for Q1, we will get Q1 is equal to 24 minus 0.5 Q2. Similarly, we need to find out the reaction function or reaction function of firm 2. It simply tells how much output firm 2 will decide given the firm 1 has decided its optimal output value level. Okay, so reaction function to find out the firm 2 is simply first find the total revenue function of firm 2, that is price into output produced by firm 2. Price function is this. To this we multiply by Q2, then we find total revenue function. Okay, multiplying Q2 to each of these terms, it becomes 200 Q2 minus 4 Q1 Q2 minus 4 Q2 square. Similarly, we need to find out the marginal revenue function of firm 2, simply the partial derivative of total revenue function of firm 2. When we partially differentiate this with respect to Q2, we get 200 minus 4 Q1 minus 8 Q2. Now, profit maximization condition for firm 2 is the same, that is marginal revenue of firm 2 should be equal to marginal cost of firm 2 here. This is our marginal unit function. We equate it with the marginal cost, which is constant here. Then we solve for Q2. That is Q2 is equal to 24 minus 0.5 Q1. Okay, this is equation first, this is equation second. What we do, we plug the value of Q1 is equal to this stuff into second equation. So we have Q2 is equal to 24 minus 0.5 in place of Q1 we write this stuff. Okay, 24 minus 0.5 Q2. So Q2 will be equal to this stuff, 24 minus 12 plus 0. So it is here 0.25 Q2. Okay, solving for Q2. So 0.75 Q2 is equal to 12, or Q2 will be equal to 16. That means output decided by firm 2 will be equal to 16. To find out the output decided by firm 1, simply plug Q2 is equal to 16 here in the first equation. So we will get Q1 is equal to 24 minus 0.5 in place of Q2 we have 16. So Q1 will be equal to 24 minus 0.5 of 16 is 8. So we will get Q1 is equal to 16. Okay, now the market price will be equal to P will be equal to 200 minus 4 into the output of this firm 1 plus output of firm 2, because Q is the sum of Q1 plus Q2. So P will be equal to 200 minus, so output decided by firm 1 is 16 and output decided by firm 2 is also 16. So this becomes 20, shall I say 32. So we get P is equal to 200 minus 32 into 4 is 128. That means market price will be 72, and the total quantity in this market, that is equilibrium quantity, will be equal to the summation of the quantities of firm 1 and firm 2. That means Q will be equal to Q1 plus Q2. So Q1 is 16, that is output decided by firm 1. Q2 is also 16, that is output decided by firm 2. So equilibrium of quantity will also be equal to, equilibrium quantity will be equal to 32. Okay, I hope I make myself clear in this video. Thank you. The question is, the currency to deposit ratio of an economy is 0.2 and reserve to deposit ratio is 0.1. The value of money multiplier is, options are being given, we need to find out the correct option. Okay, by money multiplier what we mean, money multiplier is the factor by which extra dollar of excess reserves will increase the money supply, and this money multiplier is a function of currency to deposit ratio and the what we call here reserve to deposit ratio, and it is being given by money multiplier is being given by 1 plus currency to deposit ratio divided by currency to deposit ratio plus reserve ratio. Okay, reserve to deposit ratio. Now here you can see our money multiplier will be equal to 1 plus currency deposit ratio is being given as a 0.2, and reserve to deposit ratio R is being given as 0.1, and again currency to deposit ratio is 0.2. Okay, so what will we get here? We have here, and this becomes 1.2. So we have money multiplier is equal to 1.2 divided by 0.3, and it can be written as 1.2 is 12 upon 10. This is 3 upon 10, which gives us 12 upon 10 into 10 upon 3. 10 gets cancelled, 3 ones are 3, 3 fours are 12. That means money multiplier in this case will be equal to 4. Okay, so remember this formula, that money multiplier is being given by 1 plus currency to deposit ratio divided by currency to deposit ratio plus reserve to deposit ratio. Okay, I hope I make myself clear. The question is, the demand for money defined as L is equal to 0.25y, where y denotes the income, and supply of money is being given by M upon P, that is money supply is equal to 500. In this case we are being given 4 options. We need to find out the correct option. First case is the LM curve is vertical and defined by y is equal to 2000, and this defines the classical range. Second option is the LM curve is vertical defined by y is equal to 125, and this defines the case of liquidity trap. Third option is LM curve is upward sloping and defined by y is equal to 2000. And last option is the LM curve is horizontal and defined by y is equal to 2000, and this is the case of liquidity trap. Okay, let us see how to solve this question. So what we are being given? We are being given the demand for money is being given by L is equal to 0.25 y. Here demand for money depends upon the level of income only. Okay, also money supply is being given us. Money supply is being given us is 500. Okay, now for money market equilibrium, we know that demand for money should be equal to supply of money. Okay, or let us write it in this fashion. What we are being given, demand for money is defined by L should be equal to the supply of money, that is M bar upon P. Okay, which implies L is 0.25, 0.25 y should be equal to 500. Okay, which gives us y will be equal to 500 divided by 0.25, which comes out to be the output level should be equal to, this is 5 for the 20, which is 2000. Okay, so this will be our LM equation in this case. And graphically what exactly is meant by this? So if I draw the LM curve, we have the income on the horizontal axis, rate of interest on the vertical axis. Here we have seen that income is not a function of rate of interest. If I draw y is equal to 2000 here, so it will look like this, and let me draw it here. Let us say this denotes, this is our LM curve at an output level of 2000. Okay, and here we have seen that y is equal to 2000, our LM curve is vertical, and this denotes the classical range. Normally what we have, if I draw it here and try to explain this stuff, if I have income on the horizontal axis, rate of interest on vertical axis, LM curve can be either horizontal or it can be upward sloping, or it can be, let me show it by another color, it can be vertical. Okay, now here we have seen LM curve is a vertical here. When LM curve is horizontal, it denotes the liquidity trap situation. That means LM is perfectly elastic, meaning that demand for money is perfectly interest elastic in case of horizontal LM curve. So this denotes our Keynesian range also. Okay, let's denote it by K. In case of the intermediate range, when the LM curve is upward sloping, okay, this is actually the upward sloping LM curve. This is also called the intermediate range. And when the LM curve is vertical, okay, by vertical what we mean here, the LM curve is perfectly inelastic, meaning that demand for money is perfectly inelastic. There is no change in demand for money with the change in interest, and this denotes our classical range here. Okay, since we got y is equal to 2000, we got a vertical LM curve, and vertical LM curve denotes the classical range where the demand for money is perfectly inelastic. Rather, there is no change in the demand for money with change in the interest rate. So the correct option should be the LM curve is vertical, what we got here, and defined by y is equal to 2000, what we got here, and this defines the classical range. Okay, The question is the economy of Indus, which is a hypothetical economy, grows at 6% per annum and its investment ratio is 31.2%. What is the capital output ratio for this economy by the assumption of Harrod-Domar model? Options are being given. We need to find out the correct option. Okay. So in case of Harrod-Domar, we know that Harrod-Domar model. Okay. The growth rate of the economy is being given by, that means G is equal to savings rate upon capital output ratio. Let's denote it by C. Okay. And one important assumption in the you know Harrod-Domar model is whatever is being saved is invested. That means investment is equal to savings, or savings is equal to investment in case of Harrod-Domar model. Now, if investment is being given us as 31.2%, so savings will be also equal to 31.2%. Growth rate will be equal to, now growth rate of the economy is being given 6%. So in place of G, I can write 6% is equal to, so savings is equal to 31.2%, 31.2%. We need to find out the capital output ratio, that is C. Now if I transpose this here and this there, so capital output ratio will be equal to 31.2% divided by 6%. Dividing this, we will get the capital output ratio of 5.2. By capital output ratio, it simply tells us how many dollar units of capital are required to produce 1 unit of output. Okay, and here it is 5.2, the capital output ratio, which was required here to find out. So the correct option should be 5.2. The question is, for the per capita production function y is equal to k to the power 0.5, what is the level of capital per capita at steady state, assuming depreciation is 0.1 and rate of savings is 0.4, assuming zero growth rate of population. Options are being given. We need to find out the correct option. Now this question is related to the Solow model. We are being given this equation. I have written it here. Y denotes the output per worker, which is equal to k to the power 0.5. K denotes the capital per worker. Depreciation rate, which is being given here, is 0.1. Savings rate is being given 0.4. We need to find out the steady state level of capital per capita. That means steady state level of capital per worker. Okay. The fundamental equation of the Solow model, we know that is being given by, that is change in capital stock is equal to savings times the output per worker minus depreciation times the capital per worker. Okay. Now at steady state, what happens? This change in capital stock is equal to 0. Okay. Whatever investment is being done, it is used, it goes into the depreciation. Okay, so no capital stock is added at the steady state. That implies, if this is the condition, del k is equal to 0, it implies sy minus del k is equal to 0. Okay, if this is the case, which implies sy will be equal to del k. If I transpose this minus del k, it will become positive. Now what is s? The value of s is being given as 0.4, so I can write 0.4 y output per worker is equal to k to the power 0.5 should be equal to depreciation rate is being given as 0.1 times k. Okay, we need to find out the value of k here. Now if I transpose this term here, it will get divided. We have 0.4 divided by 0.1 is equal to, if I transpose this k, it will get divided here, so we have k upon k to the power 0.5. Okay, which implies 0.4 upon 0.1 is equal to 4 is equal to, here bases are same, we can subtract the exponent, so it will become k to the power 1 minus 0.5. So we will get k to the power 0.5. 1 minus 0.5 is 0.5, which is equal to 4, which implies k to the power 0.5 can be written as 1 upon 2, which is equal to 4. Now transpose this exponent, it will become exponent but in a reciprocated form. Simple thing. So it will become k will be equal to 4 square here. That means our steady state capital per capita will be equal to 16 in this case. Okay. So the correct option should be 16 here. Is find the marginal rate of substitution between good x1 and x2 of the following utility functions. That is, utility is a function of good x1 and x2. So we are being given four different utility functions. We need to find out their MRS. Okay, so let's take the first into consideration. So MRS of this utility function, let's denote it by 1 2. That means marginal rate of substitution between good x1 and x2 is being given by marginal utility of good x1 divided by marginal utility of good x2. Okay, and negative sign obviously, because we have, since marginal rate of substitution denotes the slope of indifference curve, it has a negative slope. Okay, marginal utility of good 1 means the partial derivative of this utility function with respect to x1. So let's denote it by du1 upon dx1. Okay, divided by du means partial derivative of utility function with respect to good x1, and du upon dx2 denotes the partial derivative of this utility function with respect to x2. Okay, what will be equal to, what it will be equal to, simply if I take the partial derivative of this function with respect to x1, so the exponent becomes coefficient. So we have c, a becomes coefficient again, so we have a x1 and exponent is subtracted by 1, a minus 1. Then we have x2 raised power b. And if I take du upon dx2, again this, the exponent of b will become coefficient, so we will have c, and then we have b. X1 will remain same as it is because we are taking partials here, and x2 b minus 1. Okay, so let us write here, c and c will get cancelled. If I solve this function here, so what will we get? Let us see here. So we have a divided by b. If I transpose this x2 raised power b minus 1 to numerator, what will happen? First we have x2 raised power b times x2. If I transpose, the exponent sign changes, so plus b will become minus b, minus 1 will become plus 1. And symmetrically we have x1 raised power a here. If I transpose this term here, exponent sign will get changed, so we have x1 plus a will become minus a plus 1 here. Okay, so we have a upon b, bases are same, we can add up the exponent, so we have x2 b minus b plus 1 divided by, here we have x1, here again bases are same, we can add up the exponent, so we have a minus a plus 1, so we will get b minus b is 0, so x2 raised power 1, we will get a x2 divided by, here a minus a is 0, so x raised power 1 is x, so we will get x1 here. Okay, so this will be our MRS for the first utility function. Okay, let's calculate the MRS for second utility function. Okay, so second utility function is this. Let us first rewrite it. Let's multiply, or let us solve it. So x1 into x2 is x1 x2, then plus x1 into 1 is x1, then we have twice x2 plus twice x2 plus 2. Okay, so this is our utility function. Its partial derivative with respect to x1, derivative of x1 is 1, so we are left with x2, derivative of x1 is 1 here, so we are left with plus 1. Since no x1 is involved in the last two terms, its derivative will be equal to 0, divided by the partial derivative of this utility function with respect to x2, derivative of x2 is 1, so we are left with x1, derivative of this x2 is 1, so we are left with 2. This will be the MRS of the second utility function. Okay, now let's see the third one. Third one is this ax1 plus b x2 raised b under root x2. So let's rewrite it as ax1 plus b under root can be written as 1 upon 2 as exponent. Okay, so let's take the MRS, which is the partial derivative of utility function. First, with respect to x1, derivative of x1 is 1, so we are left with a, and divide by, now we take partial derivative with respect to x2. Okay, since no x1 is x2 is involved in the first term, its derivative is 0. Derivative of x2 raised power 1 upon 2 is 1 upon 2 will become first the coefficient. We have b x2 raised power, exponent is subtracted by 1 by power function rule, so we have 1 divided by 2 minus 1. Solving this, so we will get, here we have actually this 1 upon 2, sorry for the mistake. So if I transpose it, it will become twice a divided by b x raised power minus 1, which comes out to be minus 1 upon 2. Obviously it will become twice a, transposing again it will become since it is x2, let me write it here specifically, x2 raised power minus 1 upon 2. Okay, transposing this, the exponent sign will change, so it will become x raised power 1 upon 2, which is equal to, sorry, x2 raised power minus 1 upon 2 will become x2 raised power plus 1 upon 2. So it is under root x2 divided by b. So this will be the MRS of this very utility function. Now let's take the last one into consideration. Last one is x1 raised power a plus x2 raised power a whole raised power b. Again, du upon dx1 means partially differentiating with respect to, and let me write it here. So we need to find out the du upon dx1 divided by du upon dx2. Okay, now du upon dx1 means we take the partial derivative of this function with respect to x1 first. Okay, here we apply first the power function rule, so we have this b becomes coefficient, so we have b x1 raised power a plus x2 raised power a, and exponent is subtracted by 1, that means b minus 1. Then we apply chain rule and internally differentiate it with respect to x1. Okay, so derivative of x1 a will be equal to, so a again will become coefficient, so we have a x1 and exponent will be subtracted by 1, we have a minus 1 divided by, now du upon dx2 means differentiating again this with respect to x2. Again we apply the power function rule first, so we have b becomes exponent, we have x1 raised power a plus x2 raised power a, and exponent is subtracted by 1, that means b minus 1. Then we use apply chain rule and internally differentiate with respect to x2 this time. Okay, so again x2 raised power a, its derivative is simply a becomes coefficient, we have x2 and exponent is subtracted by 1. So here what will happen, this all stuff will get cancelled, a and a gets cancelled, we get minus is because the slope of the indifference curve is obviously negative, rather it is downward sloping, so we will get x1 divided by x2 raised power a minus 1. Okay,